Here's our last video in section 12.3. This is example number 4, talking about standard deviation. So we did in the last video an example of calculating standard deviation by hand. Remember, there was 6 steps. Kind of complicated, but once you have those 6 steps down and you can stay organized, it's not too bad. Remember, we find the mean, we find the deviation from the mean, we square those numbers, we add them together, we divide by n-1, and then we square root our answer. So really this video is just another practice of that calculation, standard deviation. In this video though, in example number 4, I'd really like you to do it twice. I would like you to do it for sample A, and I would like you to do it for sample B, and then I'd like to kind of discuss what those numbers mean. And so if you look at these 2 samples, the first thing I'd like you to notice is the data items in sample A versus the data items in sample B. If you notice in sample A, it goes 17, 18, 19, 20, 21, 22, 23. The range of those data items isn't very large. It goes from 17 to 23. But if you look at sample B, we go from 5 all the way to 35. So the range is a little bit more. Remember, range is highest minus lowest. What I'd like you to do is I'd like you to walk through finding the standard deviation for each. Okay? Remember, find your mean, deviation, square it, add them together, divide by n-1, and square root. I'd like you to pause the video. I'd like you to do it for both example A and example B, and then only come back and check your answers once you're done to make sure that you're doing it right. All right, for example, or sample A, I found the mean by adding up all my data items, dividing by 7, and I got a mean of 20. I then took all my data items, I found the deviation of each of those data items from the mean. I squared them. I added them together and got 28. I took that 28 and divided by n-1. There was 7 numbers, so I actually divided by 6. And then I square rooted that answer, and I got a standard deviation of 2.16. Hopefully you did too. Let's do sample B real quick. On sample B, I added them all together, I divided by 7, and I got the same average, the same mean of 20. Did you? So even though the numbers in our data set look very different, they still had the same average of 20. Let's go through and finish the standard deviation for sample B, and then we'll kind of compare what those mean. I'm going to take the mean, and I'm going to find then the deviation of each of my data items from the mean. I'm going to square them. I'm going to add them together. I got 700. I'm going to divide by however many numbers I had minus 1, so 700 divided by 6. And then I'm going to square root that answer. And I got 10.8. Hopefully you did too. Do you see how nice and organized I was? I'd like to see that work on your test. I'd like to see you finding the mean. I'd like to see your deviation. I'd like to see your numbers as you square them, add them together, divide, and square root, so I can see step by step where you're getting your numbers from. 1, so I can give you partial credit and make sure you're doing it all right, but 2, if you make a small mistake, I can go back and look at your work and give you partial credit for anything that you missed. So let's discuss a little bit about what those numbers mean. So if you look down at the bottom here, I have 2 little kind of charts or bell curves. I don't know if you've seen these before. Where on each of these, if this is sample A and this is sample B, do you remember that the mean was the same in both of them? The mean for both of them was 20 for each, the average. But the standard deviation was a little bit different. Remember that the standard deviation in set A was the 2.16, where the standard deviation in sample B was 10.8. And so if I'm 1 standard deviation below the mean in sample A, I would take 20 and I would subtract 2.16. If I'm 1 standard deviation above the mean, then I would add 2.16 to the mean and I'd be at 22.16. If I do the same thing for sample B, remember the standard deviation was 10.8. So if I'm 1 standard deviation below, I'm going to take 20 and subtract 10.8. Or if I'm 1 standard deviation above, I would add 10.8. And so you can see the range is very different. So let's say these were test scores. Maybe this was a math test, where this was, I don't know, let's say a science test. And let's say you scored a 16. okay? If you scored a 16 on the math test, 16 would be way over here, right? If you scored a 16, so you would be kind of below that part. If you scored a 16 on your science test, you would be in here somewhere, still kind of close to the average. And so it makes a little bit of a difference when you're talking about data items that are what we call normally distributed, of how far away you fall. In the math test, even though you got a 16 on this one and a 16 on the science test, on your math test, that actually means you did a little bit worse because you fell farther away from the average compared to that of the science test, where you were still kind of in that bubble, the normal quote-unquote bubble. Okay, we're going to talk a little bit more about that in the next section and talk about normal distribution. But make sure you know how to take a data set and calculate standard deviation. I'll have one of those on your test. So make sure you know those 6 steps and you can show me all your work for standard deviation.